such loops, I will put a star to it. Okay, either I can have 0 or more than 1, so I put a star to it. Then what is happening? Then from state k to state j, I write it as rkj to k minus 1. Any doubt? So this is the equivalent representation of Rijk. So you can inductively prove. So if you have Rij k minus 1, you can always get Rij k from here by this equation. Okay. Then what you need to do? So you first compute Ri. So for every, so I will solve a problem at that time, but let me complete this theorem first. So Rij k can be derived from Rik k minus 1 into Rkk k minus 1 star into Rkj k minus 1. So in this way, I can infer that for every DFA, I can create an equivalent regular expression of the DFA. Understood? Okay. Now, if you have any doubt, tell me so that I can clarify it. So now I will start what we call as regular expression arithmetics. Okay. Okay. So what does this mean? So first is two regular expression R1 and R2 are said to be equivalent. What does this mean? When I can say that R1 are said R2 are said to be equivalent. Tell me. If the language represented by R1, that is L of R1, is same as L of R2. Okay. So then we say that R1 and R2 are equivalent. Okay. So there are certain equivalence relations. So let me first write it down. So if R1 is equivalent to R2, this implies R1 star will be equivalent to R2 star. Can you tell me why? So what is R1 star? You remember or not? Hello. Hi guys, are you able to listen it or? Hello. Okay. Yeah. Tell me. So are you able to properly listen the lecture or not? Okay. So what I'm saying is, if R1 and R2 are two equivalent regular expressions, then I can apply the closure property over it, the clean closure, and the final expression, that is R1 star, is equivalent to R2 star. So yeah, tell me. Yeah, I can hear you. Yeah, tell me. Yeah, it's audible. Yeah, I'm listening. Okay. So what I'm saying is, if R1 and R2 are two equivalent expressions, regular expressions, I can apply closure property, and hence R1 star is also equivalent to R2 star. Okay. Similarly, I can say that R1 plus R2. So the third thing is, suppose if R1 is equivalent to S1 and R2 is equivalent to S2, then I can say that R1 plus R2 is equivalent to S1 plus S2. Okay, so these are some arithmetics we need to. So the way we need to prove it is, you take, let LR be a language accepted by, LR be the language represented by R1, and R2 is the language, LR2 is a language accepted by R2. So I can say that, so let me prove it. So let LR1 is the language generated by R1, LR2 is the language generated by R2, LS1 is the language generated by S1, and LS2 is the language generated by S2. Then first S1 is equivalent to R1, which means L of R1 is equal to L of S1. Okay, and L of R2 is equal to L of S2. Okay, now so if I put a, I have already told you what is R1 plus R2 in terms of language. It generates the language L of R1 union L of R2. Okay, now you substitute that, you will get L of S1, because L of R1 is same as L of S1. So you substitute that L of S1 union L of S2, which is nothing but the language generated by S1 plus S2. Okay, hence R1 plus R2 is equivalent to S1 plus S2. So this way the things are proved in regular expression. Now let me write some equivalence of union. What does this mean? Now first is R1 plus R2 is equivalent to R2 plus R1. You can always prove that. It is what we call as symmetric, I guess. It is a symmetric property of equivalence. Okay, so R1 plus R2 is equivalent to R2 plus R1. Similarly, if I have an empty language, epsilon plus R1, what it will be? So it will be equivalent to R1. Okay. So suppose I have R1 plus R1, what it will be? You always map it to a language and apply the set operation. Okay, so R1 means represented by LR, LR1 union LR1. What it will be? So in a Venn diagram, so only it will be LR1. Okay, so which means it is R1. Okay, now equivalence of concatenation. So let us apply the concatenation operators. So in concatenation we have R1, R2, R3 is same as R1 into R2, R3. Okay, it is the symmetric